Okay, so now what we have to do is convert the following context-free grammar to a non-deterministic PDA. And we do this precisely by following the algorithm given in the slides. So we're going to have 3 states, Q0, Q1, Q2, and Q2 is the only final state. Okay, here's how the algorithm works. So step 1 is to initialize. So that is, if we see the start state symbol from the starting state, ignoring, if we see, S on the input, and we ignore the stack, then we push, that doesn't make any sense. Let's try again. If I see ignore the input and I see Z on the stack, I go to Q1 pushing SZ onto the stack. That's better, so that's the initialize step. Second step is to expand all non-terminals. So if I'm in the working state Q1, ignoring the input, if I see an S on the stack, I could go back to Q1 and push S circle plus S, or I could push T. And if I'm in state Q1, ignoring the input, and I see T on the stack, I could push a P, or I could push Q. Okay. Step 3 is matching and popping terminals. So for all X in the set of terminals, so just P and Q and circle cross, if I'm in the work state and I see one of those on the input and I see the same character on the stack, I go to Q1 and I push nothing back. And then step 4 is acceptance. So if in the work state, ignoring the input and I see the bottom stack symbol, then I go to the final state Q2 and push nothing back. And it's totally fine to write abbreviations like this instead of writing the same rule out 3 times. As long as it's clear for all X in the set of non-terminals, if I see X on the input and X on the stack, go back to Q and push nothing. And ditto marks like this are also totally fine. I mean, you can write whatever notation you want as long as it's totally clear what it is that you're doing.